Hello friends, this is Vivek Kumar from Pseudo Analytics and I welcome you to another episode of Weekend Fun series. Today I have very interesting use case in front of you that is involving machine learning, predictions and Spotfire. So this week I have attempted to predict diabetes based on certain input variables like pregnancies, plasma glucose, diabolic blood pressure, triceps thickness, serum insulin, BMI, diabetes pedigree, age, etc. Pass those things to a model created using Azure ML Designer and consume the result back into Spotfire as an interactive application. So this is very exciting stuff, interesting, and yet very simple to implement. You can see a GitHub repository link present in front of you where you can simply go through and see all the example, all the code explained step by step by Microsoft. And I have simply consumed that code in the Spotfire as a Spotfire data function. The Python code here is simply mapped with the document properties visible in front of you on this screen, and then I am consuming back the results as well into the Spotfire, and as simple as that. To see how it works. For example, I am taking some random data. Not to mention, it is not real. There is no real person who have given this particular data set to me. I'm just thinking it out from my head, and I'm trying to change certain variables. Let's say changing plasma glucose to 104, diabolic blood pressure. Let's say leave it as 51 itself. Tricep thickness as 7. Serum insulin, leave it to 24. BMI as it is. Diabetes pedigree, let's say 1.35. Age 43 years. Try to predict it. The data function executes and it returns the result like there is 67.52% chances of that person being diabetic. Okay, let's say that lady had fewer number of pregnancy, let's say 2 kids only, and plasma glucose increases to 114. Every other thing stays same. For example, let's say just decrease the plasma glucose, leave the plasma glucose as it is, and decrease number of pregnancy, and try to check what is the effect of pregnancies on diabetes prediction. Okay, I can see if the number of pregnancies are decreasing and leaving all other data set as it is showing that the person is probably non-diabetic and having just 31.21% probability. Okay, so pregnancies are kind of after multiple pregnancy, it seems that we are getting higher chance of getting the detection of diabetes. Let's check another variable. So BMI, we will check what is the impact of BMI on diabetes. I am increasing the BMI to 39 and trying to predict diabetes. Seems that this person still is not diabetic with this kind of data set over there. Other things, variables stays in control. Okay, yet still the probability increases from other person. Let's study the effect of age. So I'm increasing the age to 56 and marking pregnancy 0. Okay. Still says that person is not diagnosed with diabetic, but probability increases little bit. Let's change the plasma glucose to 140. Okay. Now, with similar data, plasma glucose is simply indicating that that particular person is potentially diabetic with 50.26% probability. I'm changing few variables again. Let's say with a similar data set, I am just trying to decrease the serum insulin level and check what effect does it have on probability of diabetes prediction. Now, the probability of being diabetic have been reduced by 2% and person is detected as not diabetic. So Let's increase it to 28 and check the level. It has very different results now. What if the BMI stays in control, like roughly 30 as original, age as original 43, and tricep thickness increases to 9. Our data set indicates that the person is fit, he is not having diabetes at least. Okay, and with that, let's say we increase BMI a bit. Probability increases, but not that much effect on that. Let's change diabetes pedigree that to 1.45. Still similar results. Change it to 1 pregnancies. Right. We got results in all the cases. And let's change few more parameters. Let's study the effect of blood pressure on diabetes. It increases a bit, but not that much. I'm trying to change the age. Now it says that with increasing age, the risk of being diabetes is increases. So it's a very simple implementation. It is. I'm not saying that it's going to be very perfect. It is based on some sample data set and a model created on top of it. It's a machine learning model created on top of a sample data set. And if we train it more aggressively, more data, it may be more accurate. But yeah, means it's a simple demonstration of how we can consume the data generated by a machine learning model and consume it in a Spotfire interactive application with the help of Python data functions and have awesome results. So that's all for today. Hope you would like it. Please like, share and subscribe my channel and this video. In case you have any feedback, drop comments. Have a nice weekend ahead. Bye bye.